Now in this part of the tutorial, I will explain the how we can do the fine tuning of Llama 3 model by using the question answering dataset. So for that, I have taken a very simple question answer dataset. So here you can see that questions are like in the form of like a dictionary type of architecture. So question is like, what is capital of France? The corresponding context is Paris is the capital and most populous city of France. Answer is Paris. So similarly, I just put some questions, context and answers just for the demo purpose. But before going into the details, I will suggest you to install the PEPT package. This package is very important because this package is responsible for low rank adaptations facilities that we are using in fine tuning. So here you can see that how to use that low rank adaptations in your fine tuning process. A lot of codes are there. I have used a similar type of code fragments in the system. Also, you have to install the transformers. You have to install the dataset. It is just pip install datasets, pip install transformers, like that. Now the next part is you can load this dataset from this dictionary and then tokenize. For that, I have called the auto tokenizers. Now one more thing, we have used the local Llama 3 model that we have downloaded from Hugging Face. In some previous tutorial, I have given the full process how we can download the model and use it offline. Similarly, we just initialize the model, auto model for causal language models from pre-train, and after that we just set the padding. It is very important because your data, the length of questions or context may vary. So we have to apply some padding technique. It is important. Now the next part is PEPT config. So this is the main part which converts your entire. So this is the main part which converts your entire fine tuning process. This is the main part which adds low rank adaptations in your fine tuning part. So we call that low rank adaptation config. The rank of matrix is 8, scaling factor used 16, and then this is the target modules, like which are the layers you are targeting. So here we are targeting like a query projection and value projection layers, and then dropout used to reduce the overfitting chances, bias none, and the task type is like a causal language model. And based on all those configurations, we use the final updated model, and we will use this final updated model to retrain by using the training data that we prepared with the questions. For that, we will use the reprocess the data, we will generate the prompt, we will generate the data set, we will tokenize the data set, and after that we will use all those tokenized data set and prompt etc. in the training arguments. Those training arguments are directly taken from the Hugging Face. So this function contains all the necessary information required to train the required to fine tune the large language models like Llama 3. So per device train batch size equal to 1 because we are using CPU. Gradient accumulation steps equal to 8. Like accumulate the number of gradients over multiple steps. So number of training epochs just 3. Learning rate very small because we are using CPU. Logging step just 10, and then output directory where we are storing the trained fine-tuned Llama 3 package. So after that we call the trainer. It is again the trainer entire training. It will just actually based on the previous arrangements, it will train and finalize the model. So we use all the model, tokenized dataset, training arguments, and other data collectors, data collection strategies. And after that, we will just to say that config that use case equal to cache equal to false, because we have CPU with limited cache, CPU system, CPU laptop. Now we will call the trainer.train method. It will train the entire system, and then we will load the pre-trained model here. So the process is very simple. Here you can see that we started load the pre-trained Llama 3 model, initialize the low rank matrices, prepare the question answering dataset, define the Keras model for low rank adaptations layers, then compile the model with loss and optimizer that we did, and then we train the model on dataset, evaluate the model performance, fine tune, save the fine tuned model. Now after that, testing is also very easy. So just 3 is very important. Load the fine tuned model and tokenizer, prepare the evaluation dataset, iterate over dataset, and then generate prompt. And after that, continue with your cycle, like how many times you want to generate the dataset, generate the result. So tokenize the prompt, model inference, extract the generated answer, compute the actual answer, and calculate the matrices, like how accurate your answer is. So this is the test file. So again we call the trained model that we have fine-tuned and stored here. Here you can see that this is our model, fine-tuned model stored here. We are calling the tokenizer, we are calling the model, then device, just clearly assign it is CPU, otherwise it will take a lot of time in automatically fixing. And if the tokenizer just apply some padding part, here we use the tokenizer.os token so that it can automatically identify the end of sentence and padding both. And then added some evaluation data. So evaluation data, questions and context that we will pass, and answer we will use it for evaluation. So just took 2 question sets, and then we generated the prompt and then data points, and then finally generated the answer for each data points. So the system will generate the output in the form of token indexes. So we will decode it, and the decoded output will be the generated answers. So based on the decoded output, we can check our answers, that what is the actual questions, what is the generated answers, and what is the actual answer. So based on that, we can evaluate our system. So this is the process. During the training, this is actually the entire training process in the CPU takes a lot of time. So I have just recorded some training output. So for 3 epochs in 16 GB RAM CPU with i7 processor, it took 821.4515 seconds time to train for 3 epochs. So this is the entire scenario. And when we test it on these 2 questions, so actually questions are very much similar, so it has given 100% accurate results. So thanks for watching. I will make the code available through some website.